Whoops. Hey, can somebody tell me if they can hear me? Great, thank you very much. I'm a little late. I completely forgot that I had to have this stupid little mic thing. So I had to run up and find it and all that stuff because we're in the shop today. Thank goodness. I don't know if you guys like being in the shop, but it's a hell of a lot more fun for me than sitting in the office. I'll tell you that. All right, far out. 1, 2, 3, 4, 5. You guys know what that machine is right there? What do you call it? Anybody? Anybody? Bueller? Bueller? Nobody? We'll have a little chat here while a few more folks are coming in, so I don't lose them. So thank goodness we are in the shop. I can't tell you how much I'd rather be out here than sitting watching a video every day. So it's kind of nice to be back out here. I have a question for you guys. Can anybody tell me what this machine is that is on the screen right now? Does anybody know the name of this machine? Give it a shot if you would, please. Anything. Blender, toaster, air fryer. At least you're trying. Nope, but it is a saw. You got 50% of it right. Okay, 50%. Keep trying, man. I know it's hard. You guys haven't seen these in forever. Okay, but I have no problem with just shots in the dark. Okay. Thank you for trying, Regan. Appreciate it. At least I know you're listening. There's one of you listening. Okay. Well, what we have here, this yellow and I guess you'd call it gray or silver machine, is actually called a miter saw. That's M-I-T-E-R. Okay. The full name of it is sliding compound miter saw. Now, some of you may know the term chop saw. That's probably something you've heard before, is just a chop saw. This is not a chop saw. A chop saw, all a chop saw can do is cut straight down 90 degrees. That's it. Okay? That's what a chop saw does. You can't change this angle. You can't change the angle of the blade itself. Okay? One of the reasons, well, let's say one of the reasons. Here's where the name comes from. Okay? Sliding compound miter saw. First of all, the word miter, okay, indicates an angled cut. All right? So say on this board, okay, an angled cut would be something like that. Think of a picture frame and the 45-degree cuts it takes to make in the corner of a picture frame. Okay, that's a miter. All right. Compound miter. Okay, there are machines out there that are just compound miter saws. Okay, what that is if you've ever seen crown molding in a house, the molding that goes around the ceiling where the wall meets the ceiling and meets at the corners, that's a compound cut. That's two angles being cut at the same time. Okay, that involves cutting an angle this way and an angle this way at the same time. That's a compound miter. When I say compound, that means there's two angles being cut at the same time. Okay, so compound miter saw. That's where that portion of the name comes from. Last but not least is the sliding portion of the name. Okay, this is a sliding compound miter saw. All that means is that the head slides forward. What that does for this machine is it increases the width of cut capability. Okay, so if it did not slide, the widest board we could cut on here will be about 6 inches wide. Okay, with this sliding action, it gives us a width of cut of about 12 inches wide. So I can take a board 12 inches wide and I can cut it. Okay, on a regular miter saw that's not a sliding miter saw, about a 6-inch wide cut, depending on the diameter of the blade. This is a 12-inch diameter blade. It's a 12-inch sliding compound miter saw. All you guys really need to know in regards to the name is miter saw. Okay. If you're ever asked on a quiz or something like that what the name of this machine is, it is just a miter saw. That's all you have to say. Okay. So now that you know the name of this machine, all right, it has a very specific place in what we call our order of operations in the shop. The order of operations in the shop, hold on, I got somebody coming in, I'm sorry. The order of operations in the shop relates to the way in which you move from machine to machine in the shop with a piece of material. Okay? We have a very specific way in which we take a board or a piece of material and what we do to it in what order. Our order of operations in this shop is this. The first thing we do to a piece of material is thickness. We get it thicknessed. In other words, I don't know if you guys remember or not. It seems like it's been forever. Okay, this is thickness. Okay, the distance from one face to the other. Okay, that's the first thing we do. The second thing we do is width. We get it to the correct width. Okay, from edge to edge, that measurement is width. Okay, and the final thing we do to a piece of material before we start to really get it ready for use in a piece of furniture is we cut it to final length. Okay, that's the distance from one end to the other end. Okay, the miter saw is the last step in this. The miter saw is where we cut to final accurate length. Okay, so thickness, then width, then length. The machines that we use for those three things: thickness, we use the joiner, we use the planer, and we use the drum sander. Width, we use the jointer, and then we use the table saw. And then length, we use the miter saw. Now, if you look at today's modules, okay, go to manufacturing one, and we go to the modules. You'll see that on Tuesday, today, I've got some stuff going on in here, okay? So basically what it's saying is today, we're gonna go over the miter saw. We'll cover the use and safety requirements on this machine. Below is a list of questions that you will find on the safety test that cover the miter saw. There are several other questions that are on the safety test that could be considered relevant to the miter saw if you really wanted to push it. In other words, this first one right here, this true or false question, it is your responsibility to make sure each machine is adjusted properly before you use it. That question doesn't necessarily apply directly and only to the miter saw, but it still applies to the miter saw. Here's why. How do I get out of this? So I can get back to, how do I do this? Oh, here we go, stop share. Okay, so where was I before I got, oh, the question is, it's your responsibility to make sure each machine is adjusted properly before you use it, okay? This applies to the miter saw, as well as a lot of other machines in the shop, just about every other machine in the shop. What I mean by to make sure it's adjusted properly. When you guys use this machine in beginning woods, you will always use it in the same configuration. In other words, the blade will be 90 degrees to the fence, and the blade will be 90 degrees to the table. Okay, you're going to make a 90-degree cut on this machine. You're not going to cut miters on it. In the beginning woods class, you're only going to use this in a basic 90-degree configuration. Okay, you're not going to be cutting any angles on this. In intermediate woods, most of the cuts you'll make on this machine are the same configuration. In advanced woods, probably the same thing. You'll get into more miters and angled cuts in that class. But in beginning woods, you're going to use it just like this. But you need to make absolutely sure that this thing is set up properly. In other words, if you watch, this little lever right here unlocks the table. There's a little button right here. You can push it, change the angle, okay? Now there's little notches in this plate right here, along with some degree marks that tell you what angle the table's set at. If you move it, it will lock into some of those notches. Those notches relate to the most common angles you would be cutting on this. For example, a 90-degree angle, it has a stop or a positive stop at 90 degrees. It locks in right there. That locks the table, keeps it from moving. Here's the problem. It doesn't take much to bump it and knock it out of the way, okay? And it can be sitting really close to 90. You won't be able to tell, okay? You physically, by just glancing at it, you won't be able to tell. You need to make sure that it's at 90 degrees. And you can take a square, and you can bring this down, and you can slide that square up to it and see if it's at 90 degrees. And it does not look like it. Okay. You also need to make sure the blade itself is 90 degrees to the table. Okay. So that's the setup. There's another question here. Here, let's go back to that screen. Now that I think I know how to do share and everything. So some of these questions will apply directly to the miter saw and only to the miter saw, while some of the other questions are kind of all-encompassing. They can apply to a lot of different machines. So that first one, obviously, making sure each machine is properly adjusted before using it, that is a blanket statement. In other words, the table saw has to be checked, the joiner has to be checked. Most of the machines in here need to be checked to see that they're set up properly before you use them, okay? Here's another one, true or false? All wood is free from screws, nails, or foreign objects, okay? That's false. We can find all sorts of weird things embedded in a piece of lumber, from metal staples that they use to put barcodes on lumber, to rocks embedded in them. We found bullets, chunks of lead from bullets embedded in the middle of some of these boards. That's pretty rare, but we have found a couple. So that can be a real problem on our table saws, since these table saws are saw stops. They have a system in them where if the blade is moving and it touches anything metal, it's going to trip it. And there we go. There's a cost of the blade and the little cartridge that tripped. Long story. Anyway, so that's a false question. True or false? Loose clothing or hair is okay when working with power equipment. That's another false, okay? We can't have any baggy sleeves. We can't have any hanging jewelry. We do not wear gloves in this shop. Anytime you're working around rotating machinery, you do not want to wear gloves, okay? Baggy jackets, things like that. We cannot wear those things. We don't want to get caught in rotating machinery, okay? The next one is true or false. You should remove scrap material while a machine is still running. That's false. You always have to make sure the blade is at a complete stop before removing any scrap material. And tomorrow we'll take a look at the bandsaw and the drill press, I think. And that's one of the machines that's very, very important to make sure the blade comes to a complete stop, as well as the table saw and the dado saw, okay? The next one is true or false. The table saw is the best choice when cutting to length. That's absolutely false. We use the table saw. The main function of the table saw is to rip to accurate width, okay? We use the miter saw for cutting to length. The next one, true or false. You may move a guard or safety device out of the way when running machines. That's false. That's another blanket statement. Any machine that has a guard on it, you cannot move the guard out of the way when running it, okay? The next one, a board must be at least how many inches long to safely cut it to length on the miter saw? That is a question that is specific to the miter saw. We have a 6-inch minimum length requirement on the miter saw. For example, if I take a board like this, let me see if I have one. If I take a piece of material like this is a phenolic. This little guy right here, okay? This thing is just a hair under 6 inches long. I cannot come to the miter saw and cut it, okay? The board has to start at least 6 inches long to be able to safely use the miter saw. In other words, your hand is too close to the blade with this. Let me do it from this side. Your hand's too close to the blade. I still have to hold the material. I can't cut it without holding the material down. Too close to the blade. Okay, there's even little guys right here, a little sticker right here that has that red circle with the line through it and a drawing of a hand there. Okay, so minimum 6-inch length on the miter saw. Okay, the next question on here, what machine would be the best choice to accurately cross-cut a board that's 5.5 inches wide? Okay. When you see the word cross-cut or hear the word cross-cut in this shop, that means miter saw. The miter saw is where we cross-cut. Cross-cut is defined as any cut that cuts across the width of a board this way. This kind of a cut along the length of a board, okay, is a rip. A cut across the width of a board, in other words, altering the length of a board, is a cross cut. This is where we cross cut, okay? The miter saw is where we do it. Next one, our order of operations states that whenever possible or prudent, you should always mill the what of a board, then the what of a board, then the what of a board. Now that's a pretty messed up question, but all it's asking is what is our order of operations, okay? We already told you that it's thickness, then width, then length, okay? Well, I got somebody else coming in right now. Okay. Thickness involves milling the faces of a board. We talked about this some time ago. That's a face. That's a face. That's how you control the thickness of the board, by removing material from one or the other face, okay? So we mill the faces first, thickness. The width of a board, this is an edge, this is an edge, okay? Edge, edge, okay? This is how we control the width of a board. We use the joiner, we use the table saw for getting the board to final width, okay? The last is the length, or the ends of a board. We're gonna cut here, we're gonna cut here. We're cutting the ends of the board to alter the length. So in our order of operations states that we always mill the faces of a board, then the edges of a board, then the ends of a board. Faces, edges, ends, thickness, width, length, okay? Another question. The edge of your board must be tight against the blank on either side of the blade. Let me show you this question so you can see it. Here was the order of operations question. The edge of your board must be tight against the blank on either side of the blade when performing cross-cutting operations on the miter saw. What I'm talking about here, this part of the miter saw, this right here, this surface and this surface, that's the fence, okay? This surface here is the table itself, okay? The edge of your board must be tight against, let me see, I brought this board over here for a reason, must be tight against the fence on either side of the blade when cross-cutting. In other words, I have a gap. See if I've got something here I can show you a gap. Let me see if this will work. Okay. I have a gap right here. Okay, I can fit this little square, I can fit this little steel rule between it. Okay, I have a gap right here. It's touching here, and it's touching over here, but it's not touching right here and right here. Okay, if you have a gap here and here, that's going to cause a real problem when you go to make a cut. There's a very good chance that this machine is going to kick back when you make the cut. In other words, you're going to try to make a cut, it's going to get partway through the blade, and all of a sudden it's going to grab it and throw it up. Okay, that's a kickback on the miter saw. So it's got to be tight against the fence on either side of the blade. Next question is, wow, I missed the last one. That's okay. How many cuts does it take to accurately cut a board to length on the miter saw? This is an incredibly important question. Okay, really, really important question. Anytime you walk up to the miter saw and you are cutting solid stock, right? Pine, poplar, oak, alder, maple, cherry, those are the 6 species of solid stock that we have here, as opposed to sheet goods like plywoods and particle boards and things like that. Anytime you're cutting solid stock on the miter saw, it takes 2 cuts to cut a board to length. Let me show you why. All right. So I'm going to take a piece of material here and make a quick cut. So I come over here to the miter saw with a board like this. Okay. And when I want to make a cut, I have to measure from the end of the board, make a mark how long I want it to be. So if I take a tape measure, let's say I want to cut this 10 inches long. I put my tape on there. I hook the end of the tape over this end of the board. I make a mark at 10 inches. Okay. I take a square every single time. I place it on that mark. And I draw a line. I'm also going to place an X on one side of the line. I know you guys probably can't see that, but I've got a line right here and I've got an X on this side of the line, okay? So I know which side of the line to place the blade. This is the piece I'm keeping. This is the scrap material, the leftover material. Now, I don't know if you can see this or not, but if you look at the end of this board, it's got an angle on it, right? It's definitely not square, okay? You guys will see that, it's not 90 degrees, okay? I measured from here to make that mark, okay? So if I take this tape and I place it on the end I measured from, I've got 10 inches right there, okay? If I measure from this end, oh, come on, grab it. I've got like just a little over 9 inches to my mark, okay? So the reason it takes 2 cuts to cut a board to length is this. Your first cut that you make on a board is what's called a trimming and squaring cut. In other words, you have to square one in, just like this. So I'm going to take and I'm going to square this in. Okay, so now what we have is we have one end of the board that's 90 degrees. So now what I can do, now I can take my tape, I can place it anywhere on the end of this board, whether it's this end, whether it's the middle, whether it's this end, and I can measure and make my mark, and it's going to be the same. In other words, I'm going to have 2 parallel ends when I'm done. So if I take and make my mark, got my mark there, now I make my cut. Okay, now I've got 2 square ends. In other words, it's 90 degrees here. It's 90 degrees here. 90 to this edge. 90 to this edge. Okay? So it always takes 2 cuts to cut a board to length. When we make this cut, if this machine is set up properly, if the blade is 90 degrees to the table, and if the table is 90 degrees to the fence, or the blade's 90 degrees to the fence, not only have we cut a board that's consistent length, what we mean by that is this end here is parallel to this end, and it's also 90 degrees to this face, it's 90 degrees to that face, 90 degrees to that edge, 90 degrees to that edge. Same thing here, end to edge, end to edge, end to face, end to face. That's 8 separate 90-degree angles that are created with two cuts on the miter saw, assuming it's set up properly. Now, there's a couple more things about the miter saw you need to know. Okay. Anytime we're cutting more than one board to the same length, imagine the steps or the rungs on a ladder, if you would. If all the rungs or the steps on a ladder are different lengths, what's that ladder going to look like? Right? It's going to look pretty bad. It's not going to work. We need all those rungs to be the exact same length. Anytime you're cutting two or more boards to the same length, you have to use a stop. There is no way, no matter how good you think you are, there is no way you're going to sit here, make a mark at 6 inches, cut your first board to 6 inches long, make another mark to 6 inches, cut your second board to 6 inches long, make another mark to 6 inches, cut your third board to 6 inches long. Every one of those cuts is going to vary just a little bit. You're not going to have multiple pieces that are exactly the same length. We have to use a stop. And how we do it, using this little guy right here. This even says it on the miter saw stop. Has an arrow pointing to which way where the blade should be, okay, and which side should be facing you. So the blade that way, the side facing us. So if I want to cut multiple boards to say 6 inches long, here's how I do it. I take a tape, I'm going to set it right on the table, and I'm going to bring the blade down right on top of my tape. And I'm going to make sure that 6 inches line is right there on the left side of my blade because I've got the stop on the left side of the saw. Okay, I'm going to set that stop, put it right up into my tape. I'm going to take a clamp. Hopefully get it right there. I'm going to clamp that stop in place. I'm going to pull my tape away, and I'm going to double check it. I'm going to slide that tape back up, bring it down, make sure I'm on 6 inches. Okay. Now I can take my board. I can make my very first cut. I can trim and square one in. Just take enough off to square it. Okay. Now all I have to do, slide the board up to the stop. Let that blade come to a complete stop. And I can do this all day long. And I'll have boards that are exactly the same length. Okay? So that's really important, knowing how to use a stop. A couple other things about the miter saw. Basic safety about the miter saw. One of the reasons we let that blade come to a complete stop before we come back up with it is this. It can cause your board to kick back, especially if you're using a stop. So basically, let's imagine I just finished cutting this board and the blade is still turning. Watch what happens when I raise the blade. This moved, right? It's going to move every time. If that blade's spinning when you come up, not only is that board going to move, it's going to fly out of there. Okay, so we have to let the blade come to a complete stop before we raise it. Another thing you never, ever, 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 ever want to do is cross your arms when you're using a miter saw. Okay, I'm going to hold it over here, or I'm going to hold it over here, and then we're going to cross my arms like this. Okay, because if this thing kicks back, right? If I'm doing this and I make my cut and this board kicks back, my arm's going to go right into the blade. Okay, so never cross your arms when you're doing this. You're either holding it this way, or so we're going to hold it like this or like this. Doesn't matter which side. Okay, if you're more comfortable using your left hand to run the machine, that's fine. You can always put a stop over here instead of over there. Run it this way or this way. Okay, doesn't matter. Okay, never cross your arms. Next, there's a thing called feeds and speeds in the shop. Feeds refers to how fast you move fast or slow, you move a board through a cutter, like a blade or a router bit, or how fast you move that cutting tool through the board. What I mean by that is some of the machines here, you're going to move the cutter. Other machines, you're going to move the board. For example, the joiner, you feed the board over the cutter head. On the table saw, you feed the board through the table saw blade. On the miter saw, you feed the blade into the board. On the panel saw, you feed the blade into the board. Okay, so there's different ways of feeding either a board through a machine or a machine through a board. That's your feed rate. Your speed is how fast this blade is moving. Okay, for example, on a router, handheld router or a table-mounted router, most of the routers we have here are what are known as variable speed. You can change the speed a bit, anywhere from about 6,000 RPM to 21,000 RPM. The speed at which you feed a board through a cutter or the speed at which you set a cutter at makes a difference in the quality of cut. Let's look at it this way. Okay. When I make a cut on the miter saw, I'm going to do it like this. Nice and slow. I'm going to let the cutter do its work. I'm not going to force it. I'm also never going to start a machine in contact with a board. I can't start it with the blade in contact with the board. I'm going to start it up here, bring it all the way down, finish my cut, let the blade come to a stop, then bring it up. So that's a nice, clean cut. I don't know how well you guys can see that, but you'll be able to see the next one. The wrong way to do this. Okay, that's too fast of a feed rate. Hopefully you guys can see the difference in cuts. I don't know if you can see this or not. If I stand here, you can see it a little better. This is the one I did real fast, right? Look at the quality of cut. This is the one I did nice and slow. A lot nicer quality of cut. Now, some of the machines we have in here, for example, the planer, the drum sander, and our CNC machines. So, for example, I don't know how far I can rotate this, but let's try it. Let's go over here. So we have a small desktop CNC, and that's basically a computer numerically controlled router. Okay, we have a large one. I wish this thing could move at the same time. And it's got stuff all over it. This is our large bed, 4-foot by 8-foot CNC, this big blue and grayish thing. Okay, our planer, which is right here. Let's see if I can back up a little bit. You guys can see this. Okay, this is our planer. Right here, this is the back side of it. And then way over there, our drum sander. Zoom in on that guy. Wrong way. Okay, our drum sander. Those 4 machines are a good example of how we make, I guess the easiest way to say it is controlled cuts. Okay, in other words, when you feed a board into the planer or the drum sander, both of those machines have automatic feeds. In other words, they're going to grab the board from your hands and feed it through the machine at a predetermined speed. Okay? The cutter head on the planer, the drum head on the drum sander are moving at a specific speed. And the feed mechanism that pushes your board through the machine is at a very specific speed as well. Our CNCs, our CNC routers, we control the speed or the rotational speed of the bit when we program the file that we're going to run on it. So that's controlled. And then the speed at which the router head moves through the material is also controlled by the program that runs the machine. Okay, so the quality of cut on our CNCs is very easily controlled, right? You kind of have to see it to understand it, and you'll see it at some point in time here in the not too distant future. But speeds and feeds are very important. Once you start working in the shop, in a very short period of time, you'll recognize how fast to feed a board into the table saw. How fast to move a board across the router bit on the router tables, how fast to push a board through the bandsaw, how fast to drill a hole in the material on a drill press. So you'll get comfortable with that very quickly by listening to the machine, by the amount of pressure it takes to push a board through a machine. Those are things that with a very short amount of experience, you'll be able to control very easily. Okay, so actually the point is we use all our senses in here. We use our sense of hearing, our sense of touch. We very much use our sense of smell. We can tell if we're pushing a board through fast or too slow through the table saw. If the board starts to burn, okay, you're gonna smell it. On the band saws, you can smell if you're pushing too hard or too slow. So all of our senses are necessary here. This is one of the reasons we don't wear earbuds and things like that in here. So that's a really poor introduction to the miter saw. On Wednesday, tomorrow, we're going to go through probably the band saws, and maybe we'll have time to do the drill presses. And then we're going to have a short 5-question quiz on the miter saw. We'll review questions on the miter saw. Now, I want you guys to realize something. Hopefully you're listening. If you're not listening, you're going to have a much more difficult time with it. I'm going to share the screen here. I'm going to go back to our modules, okay? So if we go over here and we go to home, I can't remember where I put this, but I'll show you. And I'll also put a link in tomorrow's module. So basically, I have a website I told you guys about, right? It's www.gphsmanufacturing.org. Okay, this is my website. Well, that's because I spelled it wrong. I think that's it. Okay, so when you go to this website, there's a bunch of different choices here on the left. This is our guitar class, manufacturing class, blah, 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 blah. What we're talking about is traditional woodworking here. Okay, we're gonna click on that guy. You scroll down, and down here, you're gonna find a bunch of PDF files, okay? This is a copy of our safety test, okay? It's a blank copy of the safety test. The questions I put on today's module were all taken directly from here. In other words, true or false. It's your responsibility to make sure each machine is adjusted properly before you use it. True. The next one was all wood is free from screws, nails, or foreign objects. That's false. The next one is loose clothing or hair is okay when working with power equipment. That's false. The next one, you should remove scrap material while a machine is still running. That's false. And then we go down here a little further. The next question was the table saw is the best choice when cutting to length. That's false. And there's a bunch more here, but the questions that are on the quiz tomorrow are taken directly from this safety test, the exact same questions. It's the same safety test you'll have to pass when you come back to school before you're allowed to touch any machines in this shop and do any work in the shop. You have to pass this safety test. So any questions I ask on these quizzes will be taken directly from this test, and you have access to this test at any time, okay? Now, if I go back, the second file here is the woodshop safety test, the same safety test, but this has all the answers, okay? All the correct answers for the entire test. This copy is always available on that website, okay? I will also put it in the module for tomorrow. So if you're having difficulty with any of the questions on the quiz, all you have to do is pull this up, right? Open this copy of the safety test with the answers, find the question you're having difficulty with, and it will have the correct answer here. For example, let's see. A board must be at least how many inches long to safely cut to length on the miter saw? 6 inches, okay? Our order of operations, there was a question here on the order of operations, probably one of the harder questions you're gonna have when you take this safety test. Where is it? Where is it? Where is it? Here it is. Our order of operations states that whenever possible or prudent, you should always mill the faces of a board, then the edges of a board, then the ends of a board. That relates to the thickness, faces, the width, edges, and the ends, length. On the miter saw is where we do the ends or cut to final accurate length. So all these questions, okay, there's 50 questions, all the correct answers right here on my website under traditional woodworking, and scroll down to the bottom, okay? So if you have difficulty on any of the questions, there's gonna be 5 questions. We'll go over it again before I let you go to take the quiz tomorrow, okay? We'll go over the questions and the answers. And if you have difficulty, here's where you can find any answers you can't figure out for yourself, okay? So that kind of covers the miter saw. At some point, it would be incredibly nice if you guys did not understand something that I'm talking about or have a question about something that I'm going over, that you actually ask the question in the chat. It makes me think that you're actually listening. It makes me think that I'm not alone here and doing this all by myself. It's actually kind of nice to get questions, okay? When you guys finally come back to school, you're going to need to ask questions. I guarantee if you have a question about something, you're not the only one. Guarantee it, okay? If you can't ask questions, if you're not comfortable asking questions, you're gonna have a very, very difficult time in this class. So when we finally do come back, and I have no idea when that's gonna be, the problem we're gonna have is that you'll have at most, let's say for example, they brought you guys back at the beginning of the 3rd quarter, which is highly unlikely, but you never know. Okay, we would have 9 weeks to be here. 9 weeks to get through what we'd normally get through in 18 weeks, okay? Normally, we take 4 weeks to get through the safety test. In other words, we have 4 weeks in beginning woods where you don't touch a tool. We spend 4 weeks going over safety, proper operation of machines, shop etiquette, things like that, all the little rules and regulations and ways to do things out in the shop before you're allowed to start work. And you have to pass the safety test before you're allowed to start work. We can't take 4 weeks to do that if you're only going to be in here for 9 weeks. We have to get it done quicker. So that's what I'm trying to do, is get you prepared to take this safety test in a lot less time when you finally come back. So we're going to go over it pretty hot and heavy here in class. So if you're not paying attention, when you finally do come back, if you're in here, you're going to have a really hard time. So I implore you to please pay attention over the course of the next few weeks, because we're going to hit this safety test pretty hard. Okay. By the end of this quarter, we'll have gone over every question on the safety test out here in the shop, so that you can hopefully understand a little better than just reading the questions. Okay. So that's what we're going to be doing over the course of the next few weeks. We'll mix a few other things in there, just to keep everybody from dying of boredom. But please, please, please ask questions if you have questions. Try your best to not just go back to sleep during this class, which I do believe some of you are probably doing. I would probably do it myself from time to time. But please try to pay attention and stay on top of it, okay? So yeah, tomorrow a quiz. We'll do bandsaws, maybe drill presses. We'll move over to the other side of the shop, and we will start moving through this, okay? So if you have questions, please go ahead and ask questions. If not, that's gonna be it for today, all right? You guys, thank you for being here. Take care of yourselves, and I will see you all tomorrow morning, okay? Bye, folks. I will be here till the end of the class if you wanna stay and ask any questions, okay? I'm gonna keep this open until 9:45, all right? Bye, folks.